In one moment, Heathrow suddenly became silent. A small fire at a nearby power station was enough to shut everything down. More than 1,500 flights were canceled, around 250,000 passengers stranded, and terminals once buzzing with movement turned into echoing halls of frustration. The runways stood still, departure boards went blank, and the airport that usually roared with life became unsettlingly quiet. For the first time in decades, Heathrow's weakness was laid bare, raising a chilling question. If a single spark could silence the world's busiest airport, what does that mean for global aviation? Stay tuned to find out. To understand how such a small fire could paralyze Heathrow, we first need to look at one of its most overlooked but essential facilities, the T2 Energy Center. Opened in December 2012, this biomass-fueled combined heating and power station was designed to make the airport greener and more self-sufficient. It wasn't just an accessory to the runways, it was a silent powerhouse, keeping the lights on, the terminals warm, and even sending electricity into the local grid. The Energy Center supplies heat to half of Heathrow's active terminals, specifically Terminal 2 and Terminal 5, two of the busiest in the entire airport. That means passengers grabbing an early morning coffee, security systems scanning thousands of bags, and air bridges extending to meet long-haul aircraft all depended on this quiet but critical station working without interruption. And it wasn't just about convenience. Heathrow promoted the facility as a key part of its sustainability drive, claiming it would cut emissions and secure energy independence for decades to come. At its core, the plant has a base heating load of 9 megawatts. Enough thermal energy to keep massive terminal complexes running smoothly, and a biomass power output of 1.8 megawatts of electricity. To fuel this, the Energy Center consumes 25,000 tons of wood chips every year. These aren't just any wood chips either. They're carefully sourced within a 100-mile radius from sustainable woodlands like Richmond Park and the WWT London Wetlands Centre in Barnes. By doing this, Heathrow reduces transport costs, keeps haulage emissions low, and promotes a local energy economy. It's a clever system, at least on paper. The environmental benefits were also trumpeted loudly. Compared to using natural gas, the wood chip process was expected to save at least 13,000 tons of carbon dioxide annually. Heathrow even set a bold target of cutting its carbon footprint by 34% by 2020. Even the waste from the process, the ash left behind after burning the biomass, was recycled into fertilizer for local agriculture and manufacturing. So on the surface, the Energy Center looked like a triumph of modern engineering and green innovation. It was a facility that allowed Heathrow not just to function, but to boast about its progress toward a sustainable future. Yet, as with many complex systems, hidden weaknesses lurked behind the glossy promises. When the spark of disaster arrived, the very station meant to provide stability instead revealed just how fragile one of the world's busiest airports could be. And that's where things get really interesting. Liking the story so far? Keep watching, because next we'll uncover how an overlooked piece of infrastructure triggered one of the most disruptive events in Heathrow's history. Airports are designed with backups, redundancies, and fail-safes. From radar towers to fueling systems, nothing is supposed to stop operations completely. And yet, Heathrow's silence showed that even the most advanced systems can collapse when one weak link gives way. This wasn't just about a fire, it was about how fragile the foundation of global aviation can be. If this could happen here, where else might disaster be waiting? What you are about to hear will blow your mind. For decades, Heathrow stood as a symbol of efficiency and power. But in a single moment of silence, it transformed into a case study of hidden vulnerability. Before we get to the disaster that silenced it, we must first understand what makes Heathrow Airport such a critical hub, not just for the United Kingdom, but for the world. London Heathrow Airport is the busiest airport in Europe and in 2024 ranked as the 5th busiest in the world by passenger traffic. When measured solely by international connections, Heathrow leads globally, serving more international passengers than any other airport. In total, it handles more than 83 million travelers each year and nearly 500,000 aircraft movements. Heathrow is not just an airport, it is a central artery in the global aviation network. Located just 14 miles west of central London, Heathrow covers 4.74 square miles in the borough of Hillingdon. Its east-west runways mean planes often descend directly over the city, and surrounding communities like Simpson and Harlington have grown used to the roar of constant takeoffs and landings. The site began as the Great West Aerodrome in 1929, surrounded by farmland and hamlets such as Heathrow Farm and Heathrow Hall, which gave the airport its name. During the Second World War, the British government developed it into a base for long-range aircraft. When the war ended, it was transformed into a civilian facility and officially opened as London Airport on the 25th of March, 1946. It was renamed Heathrow in 1966. But that's not all. Expansion followed rapidly. In the 1950s, it operated 6 runways in a hexagram pattern. But as jets grew larger, this was reduced to the 2 parallel east-west strips used today. Despite operating at more than 98% capacity, these runways support one of the densest flight schedules in the world. Heathrow is the primary hub for British Airways and a central base for Virgin Atlantic. More than 89 airlines connect passengers to 214 destinations in 84 countries. Terminals 2, 3, 4, and 5 handle most of this traffic, with Terminal 5 opened in 2008 at a cost of £4.3 billion, standing as the most ambitious project in the airport's history. Together, the terminals give Heathrow a theoretical capacity of 90 million passengers annually, though congestion keeps it running near its limit year after year. Beyond passengers, Heathrow is also the United Kingdom's most valuable port by trade volume. In 2022, it handled over 1.4 million tons of cargo, much of it high-value goods like pharmaceuticals and salmon. Its top partners include the United States, China, and the United Arab Emirates, underscoring its role in global supply chains. Managing such immense volume requires tight orchestration. Aircraft are directed into 4 arrival stacks: Bovingdon, Biggin Hill, Lambourne, and Ockham, where they circle until cleared to approach. Continuous descent procedures reduce noise, and night flight restrictions curb operations between 11 p.m. and 6 a.m. Yet, despite these measures, Heathrow still records tens of thousands of noise complaints each year, proof of its proximity to residential areas. What about the disaster that happened? How could it have been avoided? You're at the edge of your seat, and it's about to get even better. Every engineer knows Murphy's Law. Whatever can go wrong will go wrong, and usually at the worst possible moment. Heathrow's darkest day proved that maxim in spectacular fashion. Late on a Thursday evening, a fire broke out at the North Hyde substation in Hayes, barely 1.5 miles from the runways. What might have been a localized electrical failure instead cascaded into the complete paralysis of Europe's busiest airport. The substation is no ordinary facility. It is designed to step down massive flows of current from 275,000 volts to a safer 66,000 volts, feeding Heathrow's sprawling network of terminals, hangars, radar systems, and cargo complexes. The system used 3 so-called super transformers, each capable of handling the load. One was placed at a distance from the others to guard against fire or explosion spreading across the site. In theory, this configuration carried an N-2 rating, meaning that even if 2 transformers failed, the third could sustain operation. In practice, Murphy's Law triumphed. All 3 transformers went down almost simultaneously as flames consumed insulating oil and equipment deep inside the substation. What looked like a design with built-in redundancy was, in reality, a single point of failure. By the next morning, the airport had gone silent. Radar screens blanked, departure boards froze, baggage belts stopped moving, and aircraft queued idly on the taxiways without clearance to depart. More than 1,300 flights were affected within the first day alone, including over 100 already airborne and forced into chaotic diversions. The airport's secondary link to the grid, routed through the Ivor substation, could not shoulder the full demand of Heathrow's small city-sized power appetite. On paper, Heathrow consumes around 55 megawatts of electricity at peak load, equivalent to the needs of a town of 100,000 residents. The backup link from Ivor was sized only for partial support. The backup generation existed, but it was no savior. Diesel generators could keep runway lights and air traffic control equipment alive for a few hours, yet they were never intended to run terminals filled with hundreds of thousands of passengers. Even the airport's much-lauded T2 Energy Center, producing nearly 2 megawatts of biomass power, was useless once the national grid feed collapsed. Its systems are designed to synchronize with grid voltage, not operate in isolation. Thus, in the space of a few hours, the heart of global aviation flatlined. The silence was not the result of terrorism, cyber-sabotage, or war. It came from a spark in a single piece of equipment, a humbling reminder that the most sophisticated machines can still be undone by their weakest link. By dawn, the impact of the North Hyde fire was felt not just in London, but across the globe. Heathrow is not a local airport. It is a hub through which the arteries of world aviation flow. When it stopped, the ripple effects spread instantly. Inside terminals, the scenes bordered on dystopian. Electronic displays went dark, queues spiraled out of control, and staff struggled to manage passengers with no information system. Security checkpoints froze as scanning equipment powered down, baggage piled high in motionless carousels. Restaurants and retail shops shut their shutters, unable to process electronic payments. Even basic lighting failed in some concourses, leaving travelers stranded in semi-darkness. For many, it felt less like the world's most advanced airport and more like a stranded train station after a blackout. Out on the airfield, the silence was just as eerie. Jets that should have been roaring skyward stood motionless at their gates. Aircraft already en route to London had to be diverted to Manchester, Paris, Amsterdam, and even as far as Frankfurt, straining airports already running tight schedules. Air traffic controllers across Europe scrambled to adjust flight plans, reroute transatlantic arrivals, and avoid congested skies over the English Channel. For some long-haul passengers, the disruption meant not just delays, but being stranded hundreds of miles from their intended destination. The economic damage piled up quickly. Airlines estimated losses running into tens of millions of pounds within hours. British Airways, Virgin Atlantic, and dozens of foreign carriers were forced to ground fleets and rebook thousands of passengers. Cargo operations, responsible for moving more than 1.4 million tons annually, ground to a halt, delaying shipments of pharmaceuticals, perishable goods, and critical supply chain components. Economists warned that each day of shutdown equated to hundreds of millions in lost trade. The embarrassment was international. Images of stranded travelers circulated across news networks. Commentators questioned how the United Kingdom, a country that prides itself on infrastructure, could allow its gateway to the world to be felled by a single fire. Politicians demanded answers. Airline leaders, including Willie Walsh of the International Air Transport Association, openly criticized the lack of resilience, calling it a clear planning failure. Yet amid the anger, the most unnerving realization emerged. Heathrow's dependence on a fragile system was not unique. Other airports, data centers, hospitals, and transport hubs around the world were built on similar assumptions of redundancy that might not withstand rare but devastating failures. For travelers stuck on the floor of Terminal 5, this was little comfort. For governments and engineers, it was a wake-up call they could not ignore. When engineers examined the aftermath of the North Hyde fire, the findings were far more troubling than anyone expected. What they uncovered was a chain of overlooked flaws that made Heathrow vulnerable long before the flames broke out. First, investigators discovered that the fire suppression systems inside the substation were inadequate. Foam reservoirs that should have smothered burning oil never fully deployed, allowing flames to leap between transformers. Had they worked correctly, at least one transformer could have been saved, and Heathrow might have limped on with reduced but functioning capacity. Instead, the system failed at the very moment it was most needed. Second, the much-publicized redundancies turned out to be less robust than advertised. The secondary feed from the Ivor substation was rated to support only about 1/3 of Heathrow's full demand. Once passenger terminals, cargo complexes, and radar towers all tried to draw power simultaneously, the system overloaded. In practice, the backup was never capable of holding the line. Third, backup generation on site proved symbolic rather than practical. The diesel generators scattered across terminals could keep emergency lighting and safety-critical systems alive for a few hours, but they were not interconnected or powerful enough to sustain flight operations. The T2 Energy Center, though technologically impressive, was designed to supplement the grid, not replace it. Its 1.8 megawatts of biomass electricity barely scratched the surface of Heathrow's 55-megawatt appetite. The consequences extended beyond electricity. Investigators reported that Heathrow lacked a comprehensive plan for maintaining operations in a prolonged grid outage. Staff training focused on evacuations, bomb threats, or cyber attacks, not on the prospect of total electrical collapse. As a result, employees scrambled without clear protocols, worsening the chaos. Meanwhile, airlines and regulators demanded accountability. Executives from British Airways and Virgin Atlantic pressed for answers on why the world's busiest airport could not secure a resilient energy supply. The Civil Aviation Authority launched inquiries into whether Heathrow had met the standards expected of critical national infrastructure. Comparisons were made to airports like Singapore, Changi, and Dubai International, both of which maintain independent gas-fired generation capacity on-site precisely to avoid such crises. Against those benchmarks, Heathrow looked dangerously underprepared. What emerged then was not a story of an unavoidable accident, but of decisions made over decades to prioritize cost efficiency over resilience, to rely on partial redundancies instead of full ones, and to trust probability models instead of preparing for worst-case scenarios. The silence at Heathrow was not just caused by fire, it was caused by planning choices. For Heathrow, the blackout was more than an isolated incident. It was a wake-up call about resilience in modern aviation. On one side, there are the glossy promises of sustainability and efficiency, built around facilities like the T2 Energy Center. On the other, there are the stark realities of fragile systems that can collapse from a single spark. The fire at North Hyde showed that progress in green energy means little if reliability is sacrificed. Heathrow's silence wasn't just the result of flames, it was the outcome of decades of choices, balancing cost against redundancy, probability against preparedness. The pressure isn't only operational, it's political, economic, and global. What happened at Heathrow forces the industry to ask, how do we build airports ready for the next century, not just the next quarterly report? Some airports showcase power, others expose weakness. Heathrow did both. In one moment, it stood as a symbol of innovation, and in the next, as a lesson in hidden fragility. What happened there isn't just a London story, it's a global warning. If the world's busiest airport can be silenced overnight, what does that mean for the rest of us who rely on aviation every day? That's why we tell these stories, because behind every smooth departure lies a network of risks we rarely see. If you found this breakdown eye-opening, make sure to like, subscribe, and join us for more. From silent runways to groundbreaking technology, we'll keep uncovering the truths that shape our skies. And if there's an aviation mystery you'd like us to unravel, drop it in the comments. Your idea might just be our next flight.